Welcome to The Explainer. You ever wonder how a simple click on a website magically turns into a personalized recommendation? Well, today, we're going to follow that exact journey of data. We'll go from just a raw question all the way to a real-world answer. And yeah, we're going to do it all in about 5 minutes.
Every single powerful data project, it starts right here. And believe it or not, it's not with complex code or these huge servers. Nope. It all begins with a simple, driving question. Because really, before you can even think about finding an answer, you've got to know exactly what you're asking.
So what is this stuff, really? Honestly, the best way to think about it is like being a detective. Data science gives you the tools, the methods to sift through all the noise, find those little clues hidden in the data, and ultimately solve the big mystery that your question kicked off.
All right, Section 1, the question. Let's go ahead and lay the foundation for this whole project.
The whole process, from start to finish, can really be broken down into a pretty clear 8-step journey. This is what takes an idea from just a concept all the way to something real.
And here it is. This is basically our roadmap. Now, what's really important to get is that this isn't a straight line. It's more like a cycle. We kick things off by defining the problem and getting our hands on the data. Then comes the really critical part, cleaning and exploring it. Only after that do we start modeling and evaluating. And finally, we deploy the solution and monitor it, which, you guessed it, often leads us right back to new questions, starting the whole cycle over again.
Okay, on to Section 2, from raw data to insight. This is where we really start to get our hands dirty with the foundational work.
All right, now this part, it's maybe not the most glamorous, but it is absolutely essential. We're gathering data from all over the place, and then we have to clean it all up. Handling missing pieces, standardizing the formats. We even do this thing called feature engineering, which is kind of like a chef creating a brand new ingredient from stuff they already have, just to make that final dish, our prediction, even better.
I mean, let's be real. Just staring at endless rows of numbers isn't going to get us very far, right? That's where data visualization comes in. It's how we turn those boring spreadsheets into actual stories. It literally lets us see the patterns, the trends, and the weird outliers that would just stay hidden otherwise.
All right, Section 3, teaching machines to learn. Now that our data is all prepped and ready, it's time for the really cool part, building the brain of our solution.
Now, this isn't about writing a bunch of if-then rules for a computer to follow. No way. Instead, we feed it all that clean data we prepared and let it learn the patterns for itself. The whole goal is for the algorithm to get so good at recognizing these patterns that it can make super accurate predictions on totally new data it's never seen before.
And generally, machines learn in two main ways. First, you've got supervised learning. This is where we give the model data that already has the answers. It's like giving a student a practice test with an answer key. Think photos already labeled cat or dog. Then there's unsupervised learning. Here, we just give it unlabeled data and basically say, go find the interesting structures on your own. It's like being an explorer discovering new territory, say by grouping customers into different segments without any pre-existing labels.
So what this all means is you have to pick the right algorithm for the job. If you're doing a supervised task, like predicting a house price, you might use something called linear regression. If you're trying to classify whether an email is spam or not, you'd probably use logistic regression. But for an unsupervised task, like finding those natural customer groups we talked about, an algorithm like k-means clustering is the perfect tool for the job.
Okay, but let's be honest. A brilliant model just sitting on a data scientist's laptop, it's not really doing much good. To make a real impact, that model has to be put out there, integrated into a live production environment.
This whole process is called deployment, and you can think of it like getting a dish ready for service in a professional restaurant. First, we have to package our model up nice and neat. Then, we create a kind of service window, that's our API, so other apps can come up and place an order for a prediction. And finally, we put the whole thing in a standardized container, like a to-go box, so it works perfectly in any kitchen, or, in our case, on any server.
So, in short, deployment is that final, absolutely critical bridge. It's what connects all that complex data science work directly to the person who's actually going to use it, whether that's through an app, a website, or some internal business tool. It's the step that turns our model from just code into a real, tangible, valuable asset.
So we've gone on this whole journey, right? From a simple question all the way to a deployed model. But what does it all really mean? Well, let's take a look at where data science is already out there shaping our world.
Believe it or not, you interact with this stuff every single day. It's humming along inside factories, predicting when a machine might fail to prevent those massive shutdowns. It's the engine powering your personalized shopping recommendations.
It's that silent guardian watching over your credit card for fraud. And it's even becoming this crucial assistant for doctors, helping them spot signs of disease in medical scans way earlier.
So, as we've seen, data science isn't really just about numbers, is it? It's a structured process for turning curiosity into real capability. It takes abstract information and forges it into tools that solve actual, real-world problems. People say data is the new oil, the raw material of our time. So the only question left is, what problem are you going to solve with it?